Hey, so a very good day to everyone watching this. So my name is Sharvin, and today I'd like to talk about my FYP2 and what I've achieved so far. So as you all know, previously in FYP1, I did a brain tumor recognition system. So basically what I did was I fed MRI scans and then I would compare the actual MRI scans with the algorithm and see how accurate it is in determining the brain tumor. So basically in FYP1 I did it with 2D images, and in FYP2 I'm trying to do it with 3D images. So basically I started by adjusting the structure. That means I adjusted the CNN, the neural network, the convolution. So I did was use I edited the UNet structure. So basically, yes, I added some 3D max pooling. So because pooling helps to reduce the batch sizes and help to make this segmentation easier. And besides that, I also added uh, two or three more extras value, and I also did add one or two extra convolution. So but then we did follow I did replace them, so that's why the number of layers are still the same, and I rather stick to this 58 layers because it matches very well with my CPU and GPU capacity. So this, after running this, basically you will get like a 3D structure, like a base on which it would work on. So the base can be viewed by using one of the already built-in apps. So we have here the volume viewer app. So it can be seen, yeah, right about here. So basically this is the base which is going to be used, and then what happens is I would feed the MRI brain tumor data which I got from the Brett's data pack from the Traeger website. So at the same time, I'm going to be feeding it into this base and try to plot the brain tumor into a 3D volume. So I'll show you an example. Let's say if we take number 4. So this is out of 55 test images which I used. So yeah, I was a bit limited to my hardwares because I don't have a very high-end computer, and I also couldn't use the cloud computing method, because if you need cloud you need to buy or rent their cloud storage. So okay, so let's say we take number 4, and I'm going to just run it. So yeah, so this was what you all saw last time, the 2D structure, and then now in 3D it's going to appear like this. So there, over here. So basically the ones on the left is the actual data, the ground truth images, and the one on the right is the predicted data, which means predicted by the algorithm. So it's pretty accurate. It is able to detect exactly where, and especially in a 3D manner, so this would really help a lot. So okay, let's say we take another one. Let's say if we take image number 36. So okay, so basically brain tumor is over here, and in 3D, yeah, so you can see it is pretty accurate in predicting the images. This is a frontal view, you can see. So this is the back view, yeah. So yeah, so it's quite good. So as you can see at the bottom over here, the average die score 0.9982, and then from the system, that means the algorithm, 0.78, because there are still a bit of classification issues. Like for example, if I were to show you test image number 50. So okay, so as you can see, the tumor is inside over here. This is the top view, and then if I were to run it in 3D, so there, So as you can see, it's over here. So this is the actual result. And then in the predicted element, so yes, it is able to detect also, but at the same time there is a bit of um, bugs and whatnot. There's also a little bit of data loss because the data which I used became a bit corrupted. So as you can see, we have a bit of inaccuracy over here because the tumor is just at this region and not at this region.